Hey geometry class, we're going to be looking at section 7.2 in this lesson. It's about the Pythagorean theorem again, but the converse of the Pythagorean theorem. So let's go and get started. Right here is our converse of the Pythagorean theorem. It says if a triangle or if a square of the length of the long side of a triangle is equal to the sum of the squares of the length of the other two sides, then the triangle is a right triangle. So what that is saying there is if this right here, this formula is true and these are equal to each other, then what you have is a right triangle. All right, let's look at an example. So in these first two examples, we are asked to tell whether the given triangle is a right triangle. So you follow the formula as we've done before. We are not given that this is a right angle because we are trying to determine whether or not this is a right triangle. But how you want to use this formula is it's right here, c squared equals a squared plus b squared. Plug in your numbers. The largest number is always going to go in for c because your hypotenuse is always the longest side of your triangle. So that is this one right here, 3 times the square root of 13. Plug that in and square it. And then put your other two side lengths in for a and b, like so. And evaluate this. You can straight plug this into your calculator as long as you put your whole value of 3 square root of 13 in parentheses and then square it. Don't try just plugging this in your calculator and then saying square. It'll only square this value right here. And whenever everything's in parentheses like this, 3 needs to be squared and the square root of 13 needs to be squared. So what you have here is 9 times 13, which equals 117. And then this side of the evaluate that side, and you also get 117, which makes this statement here true that these two sides are equal to each other. Therefore, we have a right triangle. Okay, let's look at this next example. Do the same thing. I'm going to plug in 29 for C. And then determine if the other two side lengths squared are equal to that. So 24 square it plus 16 squared. Well, 29 squared, you get, let's see, 841. And then on this other side, when you do this and evaluate, you get 832, which means they're not equal to each other because they're different. And that means when they're not equal to each other, you do not have a right triangle. So not a right triangle. Now to go along with the previous theorem that we looked at, we have two other ones that correlate to it. So the only other two types of triangles that you can have according to your size of your angles inside your triangle are acute and obtuse. So this theorem right here, it says if the square of the lengths of the longest side of a triangle is less than the sum of the square of the lengths of the other two sides, then the triangle ABC is an acute triangle. So whenever this statement right here is true, and this inequality symbol is less than, you have an acute triangle. Now this whole thing is the same thing down here, except you have greater than. So you're going to put all your values in for A, B, and C. And if this symbol right here is a greater than symbol, you have an obtuse triangle. Okay, so let's put this into practice. All right, so we're going to classify whether these numbers right here, which refer to their side lengths of a triangle, we're going to decide whether the numbers can represent as side lengths of a triangle. And then if they can, classify the triangle as right, acute, or obtuse. Uh, if you remember from one of our chapters, we determined whether three numbers that correspond to side lengths of a triangle can or cannot be a triangle. You do the triangle inequality theorem. So do this right here. Say 5 plus 12. That has to be greater than the third side. And then 12 plus 13. That has to be greater than the third side. So rearrange all of three of these values into three different inequalities, and you get all of these statements here are true. So this is a triangle. Now we're going to classify it by using our theorems that we just looked at. So using the c squared, and you don't know what goes in this box, an equal sign, a greater than, or a less than symbol. Okay, so whatever goes in here is going to help us in determining whether it's right, acute, or obtuse. Okay, so like I've said before, C, always pick your largest number that you have. In this case, it's 13. And then your other two side links go in for A and B. Well, 13 squared is 169. And this other side of the equation is also 169. So these are actually equal to each other, which means this is a right triangle. And we're done. Okay, do this all over again with what we did here, and you should be able to determine that, yes, this is a triangle with these being the three side links. Okay, so let's go ahead and skip to this portion. So c squared, a squared plus b squared. All right, so 6 is our longest side length given. And then plug in square root of 8, square that, and then 4, square that. Now we need to calculate both sides. So this is 36, and then this side is going to give us 24. So this, the side where the hypotenuse is greater than the other two side lengths put together. So what we have here, if you follow the definitions that we just, or the theorems that we looked at on the previous page, this right here means we have an obtuse triangle. Okay, now let's do one more, and then the next three I'm going to ask to do as your lesson quiz, and we'll go over those in class tomorrow. So again, start with this right here, determining whether these are triangles, the side lengths give you triangles or not. And I'm going to skip to the next portion because it will give you a triangle. And this right here is going to be my C. I'm going to go ahead and plug it in, 28. Let's figure out what that box is going to be. Then 20 squared plus 21 squared. 28 squared, see, gives us 784. And then the other side gives us 841. Okay, so this right here, whenever we have a less than symbol in between our two values, this is going to give us an acute triangle. And we're done. Like I said on the previous page, do these three problems as your lesson quiz, and we're going to skip on to the next portion. So this, we are asked to graph points A, B, and C, and to connect the points to form triangle ABC. Then we're going to decide whether triangle ABC is right, acute, or obtuse. And you'll find out that whenever we do graph points A, B, and C, let's go ahead and do that. It may look like you've graphed a right triangle, but it's sometimes it's not. You can't just go by looks of the triangle. So right here, I'm going to call that my point A. Over here is point C. Right here is B. So when you connect, that's horrible. Let's see, connect. These. It may look like this, these two lines right here at angle B might be a right angle. Well, what you have to do to determine whether you have a right triangle or not is again use the Pythagorean theorem. And how we're going to do that is we're going to come up with the distances for AB, BC, and AC with our distance formula that we learned previously to this chapter. So just to remind you of the distance formula is this right here. x2 minus x1, square that, add that to y2 minus y1, and then square that. Then you take the square root of everything. So let's find the distance of AB using these two values right here, A and B. We're going to get 0 minus negative 3, so 0 plus 3. Square that. Add that to negative 2 minus 5, and square that. And then do the calculations for this, and you end up having AB is equal to square root of 58. And just leave it as square root of 58 for now. All right, now let's find BC. Find the length of that. Again, use the distance formula, but this time let's use points. Oops, didn't mean to do that. Use points B and C. To make up the line BC, you have to use points B and C. All right, so these 2 points right here. I'm going to say 4 minus 0 squared plus 1 minus negative 2. And 1 minus negative 2 is 1 plus 2. Okay. That calculation is going to get us, let's see, square root of 25, which is 5. And then let's do AC. So instead of using points, these 2 points like we did in the last one, we're going to be using A and C, these values. So square root of 4 minus negative 3 minus negative 3, so 4 plus 3. And then 1 minus 5, square that, and then evaluate that. It gives you square root of 65. So now all of that work to get you all 3 side lengths of your triangle, so you can plug it into the Pythagorean theorem and estimate whether this is a right, acute, or obtuse triangle. And this right here, 65, or square root of 65, that is the longest side on my triangle. So I'm going to make that my hypotenuse that I plug into my Pythagorean theorem. So square root 65 squared equals the other two sides, square root of 58 squared plus 5 squared. Now, do all the calculations for this. You get 65 on this side, and then on this side, you get 83. So they're not equal to each other, so it's not a right triangle. And this side is less than the other one. So this right here is an acute triangle. And also, as part of your lesson quiz, I want you to go ahead and do this problem. Graph it and do the exact steps that I did here to find lengths AB, BC, and AC. And then use the Pythagorean theorem test here to figure out whether it's right, acute, or obtuse. And that actually concludes what I have for y'all today. And I will see you all in class. Goodbye, everybody.